Hi there, this is Matt Heffernan, and welcome back to my channel. This is the 8th episode of my series on the Xci tutorial. Xci is the extremely compact interpreter, an adventure game engine that I'm creating for the Commander X16 retrocomputer. If you've seen any of the previous videos, you'll know that we've gone through a lot of the different ways that you can create content for the game, and we've been in these last few videos talking about the actual level design and how you can create animation. And we had touched before in some videos about how we deal with state. And in this video we're going to be concentrating on Boolean states. Now if you don't know what Boolean means, that means chances are you're not a software person by trade. So in case you didn't study computer science, or if you fell asleep during math class in high school, a quick refresher here. Here's this guy, George Boole. He was a 19th century English mathematician, and he basically invented logic as we know it, binary logic, zeros and ones, or true or false, and came up with a lot of the very basic mathematical concepts behind computer science as it has become. And so in computer science we talk about Boolean values as being either true or false, nothing in between. And that's what Boolean states are. So with Xci, you can define however many Boolean states that you want. Well, up to a certain limit. We'll get to that. And there are a few different commands, different instructions that you can place in your game to deal with those. And generally what we use states for, Boolean states, is for branching within different sequences. So controlling based on things that have happened previously, what are you going to see now? How are different interactions going to go down? And this flowchart you see right here, it looks a little complicated, but it's common sense for the most part. If you've done any programming before, it's something that would be very familiar to you. So let's just go through in a very gentle way to talk about what this means. So each Boolean state starts out as false. Until it's defined explicitly, it's just false. And from there, you can either set the state, which makes it true. You can clear the state, which explicitly makes it false, but that doesn't really change anything. And then you can use that state in if or if not sequences. And by default, since it's false, if the first time you reference a Boolean state is with an if statement, it is that if statement, the subsequence inside that will not be executed. It's just going to jump right to the corresponding end if. But if you reference that in an if not for the first time, then you will execute that subsequence after that if not statement, and then all the way until that corresponding end if. And then at the end of that, this subsequence could actually alter that state, and it could make it true or false. We don't know, so that's why we have this little question mark right here. But if we do a clear or an if, we know it's going to remain false. But once it's true, then we handle these things a little bit differently. If once it is explicitly set to true with a set state, if we hit an if not, that is going to be short-circuited to its end if and will remain true. But if we hit an if statement for that state, then it will execute the subsequence under that, which may or may not change that state. And then after the end if, we don't know what that state is. But once it's true and we hit that clear state instruction for that particular state, then it will go back to false. And that's it. That's the entire life cycle of a Boolean state. It's really quite simple, and that's why this shouldn't be a terribly long video. If you want to go back, and which I highly recommend, go back and look at the documentation I have here. Oh, there's George again. Hi, George. George didn't look like a really fun guy, but all the computer games and everything you've ever played is a result of him. So, little shout out to George Boole. So looking here in the main documentation, under the level file keys section of the document, we can see all the different instructions that are used for levels. And starting here with set state, we can see here all 5 keys that are used for dealing with those states. And then if you look at the Xci Syntax guide, then you can see a little more formal approach to how we define if and if not. And you can see each of these instructions only has a single argument, and that is the name of the state. And the state is just an identifier, so it can be any sort of alphanumeric string. Generally, you're not going to have any escape sequences in it, so unfortunately no backslashes or pound or hash symbols in it. But anything else, pretty much, that doesn't include white space, from whatever you after the if or whatever instruction key you have, you'll have a white space, and then you'll have the name of a state, and that will define it. The first time it shows up there, that will define that state. And like I said before, it's initially going to be false, and until you do an actual set state. And pretty much whatever you call it, anything that's after that first white space, after the if, and then that string leading up to the next white space, that is going to be the next white space, or new line, of course. That's going to be the name of that state, and you have to use that over and over again. And it is actually case sensitive in this case. I'm pretty sure. I only designed the thing. I don't remember, but I'm pretty sure that it's case sensitive. It might be case insensitive. Go ahead and do it like case insensitive, because you don't need to confuse yourself for your own game. All right, so there you go. So if not, end if, set state, clear state. Real simple. And we've already just gone through, because the concept of states are so simple. When we did our tutorial game, oh, that's not it, this one over here, in that level 1, we went ahead and just started adding it. We're only dealing with a single state here. If we look at what it starts out as, here we got these bananas and the Holy Grail, and that's what we put up initially. So the first time we have the first sequence. We always say we're here in the init, and then after that, if it's the first time we're here. Now, this first visited is a sort of implicit Boolean state that you can't really set or clear. That is entirely under the hood, but effectively works the same way, because you're only visiting a level for the first time once. And so since it is the first time, it goes ahead and says, buy something, will ya? And puts up the tiles for the bananas and the grail. And it doesn't actually explicitly set any states in there, but very often in your first sequence is a lot of times where you are going to create initial values for your states, if your initial value is supposed to be true, or if it's a state that you're reusing from a previous level, and the first time you come to a level you want to reset it back to false, you'll do a clear state. And then here we look down and we have some triggers. Let me bring this guy back up here. So we have the default trigger for bananas is used. We see our little hand come up, and that's just, there's nothing at all conditional in there. So we can just keep doing that as much as we want. We can use bananas, and it says, yep, they're 3 for $1, and we can just keep doing it, and it'll keep doing that. Yes, bananas are 3 for $1. And here, though, for this other use trigger for a different part of the screen, which is where the grail is, it says grails are one easy payment of $9,999. Here, I'll click it again, because here, though, there's only one grail. You know that if you've watched King Arthur, there's only one grail. And once you've bought it from this level, it doesn't come back. So we want to make sure that you don't have the grail. So if not got grail, then go ahead and say, yep, I got somebody clicking on the grail, so I'm going to print that text. If the grail's not there, like, for instance, we go down to our inventory, we select our money, and we buy that grail, we've got the grail, because we can go down there in our inventory, and we see we have less money now, but one grail. And that's not there anymore, you'll see. Well, I still have that use trigger. You can see the actual little cursor comes up. It changes to the hand, so that trigger is still right here, this trigger. It still actually fires up and said, yep, there's a default use trigger there, But if I click on it, you notice nothing happens because got_grail has actually been set now. And how did that happen? Well, when I went to the inventory and got out the money, and I had 9,999 monies to give, so I was able to pay for the grail, and I didn't already have it, so it went ahead and got the item, added it to the inventory, and then it set the state. It set the state of got grail, and that now is persistent throughout the rest of the game. That got grail state will be set until it is explicitly cleared. And then you can see here it hid the sprite for the grail and put out the text, you got the grail. But that won't happen again. If I try to do the money, also in that area, nope, nothing happens. So yeah, in this case, we're using if-not statements to prevent us from doing things that wouldn't make sense, because there's only one grail. We don't want to buy another one. But you know, since with bananas, we don't have that issue, so I could go ahead and buy bananas. There we go. I got some bananas. And I look at my inventory, and there's more bananas. And I can keep buying bananas because there's as many bananas as I want. So it doesn't go away. And we can see there in my inventory, yep, now I've got 6 bananas. So that's a sort of the basic way that you could use state. And that's how a lot of interactions are going to go down, especially when you're talking about gathering inventory items in your game. So to go back to the slides here, we're done here with this flow chart. So a bit of a word I touched on earlier of state persistence. So across all the zones and levels of your game, when you set the state or clear the state, that Boolean state does not change until you do another set or clear within another level, that is. And also then that state will persist if you do a save game and then restore using that saved game. That state will be brought back to its previous state, whether that was true or false. So it's really how we determine what's happened in the game and how we actually define the sequence of events that happen. And you have up to 386,544 individually named states that you can have in your game. And but you can still reuse them, because quite often a lot of these states, once you've gotten past a level and you don't go back to it, you don't really need that state anymore, and you can kind of reuse it. You could use more common names. But if you wanted to get really fancy with it, and you could have pretty long state names, and you could get really, really, really specific about all these different states. But the big thing that states really help for is when levels are reentrant or have multiple triggers in them, like we saw with the last one. But the most absurd example, if you've seen the video I posted for this a couple months ago, is my Tic-Tac-Toe game. Here's the code for it. It's basically 2 levels, and here's that first level, which we can see here in level.xci. Where here it puts in tiles, draws some white tiles on a black background, and then it gets into some states and says, all right, well, if x1, then let's draw an x. If O1, draw an O, and those all refer to, the different cells here in the game. We don't need that anymore. So x1 means there's an x here, O1 means there's an O here, x2 means an x2 here, O2 means an O here, and so on. And so we use that init to say, all right, here's what's going to happen. I'm going to draw all these, and then here we get down to the bottom, and then we can say, hey, if we've advanced since the last time that we were at this level, we can go and say, hey, if we were first, then we're clearing that state first, we're on to the second. And so here we can see we have this sort of iteration count. Since you don't have numerical variables, you're going to have to make do with Boolean variables. And this is a method that you can utilize for your own things where you can basically just do words like first, second, third, and fourth, and sort of clear and set them as you go on. But you can see here in the first sequence, that's when I actually set that state first, so that when I first open the game, that's going to be true. And so then, if it's advanced, this advanced state is not going to be true when I first start the game, so it's not going to advance me to the second iteration. In order to do that, I have to get through some other stuff. So advanced only gets called here if we don't hit a draw situation. We go ahead and set the advanced, and that's at the end of each of these triggers. So let's take a look at these triggers. Now, if you'll notice that unlike in the init sequence where we're doing a bunch of graphics commands, in these triggers there's almost no graphics commands. It is all Boolean states, and that's how I implemented this sort of basic AI state machine to play tic-tac-toe against you. So that taking a look at seeing where X's and O's have already been placed on the screen and how many iterations into the game we are, and then using this established sequence that I had found on Wikipedia, of all places, that's where all good knowledge is. It got me a way to make sure that a computer will always at least draw against you, and you can let it win, but it makes it impossible for the human player to ever win, even if they go first. And that's why we can see here, I could start in the middle and think I'm smart, and oh nope, it's just gonna foil me every time, and oh, I didn't look what I was doing, and there I let it win. And then it tells me how stupid I am, because we can see over here that yes, I've advanced to the loser level, and it redraws all these tiles and then says, oh yeah, we're going to draw all those X's and O's like last time, but we're going to add to that a left line. And so all of these determinations were made back here, where I could see I set that state of left line by determining that there were O's in each of these cells. So after loading that, I saw that, yeah, left line, where is it? I'll find it in here somewhere. All right, so let's go all the way up here. Center line, left line, there we go. So then I see, yeah, if there's an O in the 7 spot and there was a O in the 1 and the 4 spot, that means there's a left line, and then I'm going to go to level 01, which is the loser level, and so on. That's just a lot of ways how you can really add some clever interaction to your game, or maybe not so clever, but you can do more than just deal with things being there or not and just controlling animation. You're controlling actual game logic and having real loser-win situations. And that's pretty much it. That's how you use Boolean states. So I hope this was a bit enlightening for you. It's not as long as some of the other videos that I've had, but this was a pretty simple concept, and I hope you enjoyed the series so far. If you haven't already, please subscribe to my channel. I've got lots of more videos on here. I've got demos of Xci, demos of other things I've done for X16. And if you hit that little bell icon, then you'll get notifications of when I post new videos. And most of the videos I'm posting right now are the episodes in this. So I've got a few more episodes to do before I'm done with this series. And I hope to have a complete series of nicely educational videos for you to go out and create your own adventure game. And if you like adventure games, love adventure games as much as I do, that seems to be a really good way to spend your time. A lot of us have an extra time right now and are looking for ways to use it constructively. I think this is an excellent opportunity to go and I never got to really create the kind of games that I liked when I was a kid back in the late 80s, early 90s, if you're about my age. And it's like, no, I can actually do that now. I can do it and keep it sort of old school, make it an 8-bit machine hit its maximum potential. and really create an interesting and fun way to tell a story, and to not just say that, oh, during this crisis, all I did was stay home and watch TV. No, I actually created something. I can look back on this time as a period where I actually contributed something positive to the world. So that's my hope for you. And please take care, stay safe, stay home, and I'll talk to you again soon. Bye-bye.